All right, in scenario 3, we're going to look at a can, a cylindrical can, okay? So it talks about holding 60 cubic inches of material. So inches cubed is volume, so that tells me we're definitely dealing with the volume formula of a cylinder. And it tells us that that is 60, so I can go ahead and actually plug in 60 there. And then it says, what dimensions will minimize the cost of the can? What dimensions will minimize the cost of the can? Well, if we're talking about the dimensions, that would be diameter and height, okay? And the way that we can get that information is from our surface area. Well, the surface area formula is 2 pi r squared plus 2 pi RH. And the reason it would be surface area is because it's talking about the dimensions to make the can. If you think about the can, that's the surface area. The liquid inside the can is the volume, but to actually make the can would be surface area, all right? And so now what I can do is I can solve for H in my volume formula, since that's the easiest variable to solve for. And I can plug it in here. So then if I do that, and then if I simplify that, that'd be 120 divided by R. Okay, and so remember, after you get two formulas to be in terms of one formula and one variable, so we have like radius as our one input variable, now remember that's where you take the derivative, okay? So if I'm going to take the derivative, I want to rewrite that 120 divided by R as a power, so that'd be 120 R to negative 1. And now I can find the derivative. So if I take the derivative, you know that's 4 pi R plus, actually minus 120 R to the negative 2. And again, because I know I'm going to have to like set it equal to 0 and move stuff around, I can change that R to the negative 2 to be divided by R squared. Okay, and so remember our next step after taking the derivative is to set it equal to 0 to find the critical points. And so if I do that, I can add the 120 over, the 120 divided by R squared. And now I could cross multiply to solve. So I'd have 120 equals 4 pi R cubed. Divide off that 4 pi. If I divide off that 4 pi, would I get 30 divided by pi? Equals R cubed. So then I could get R by itself by cube rooting it, right? And so it wants the dimensions of the can. Well, if that's the radius, you know, the diameter is just double that. So the diameter is going to be 2 cube root of 30 divided by pi. Since the radius and the diameter is just double that. So that's one dimension. And what is it? Inches. And then your height, you could find your height. Because remember, right here, all you got to do is plug that in. Well, plug in the part that's the radius. So actually I should say plug that into the radius and see what you get there. And that's it. That's the dimensions in scenario 3.